Hello friends, so today in this video we will create a weapon detection model, or you can say the gun detection using you can say the model which we are using is, let me show you. The model which we are using is faster RCN ResNet50 FPN. Okay, so let's get started. So before that we have to install the Roboflow because we need to download the dataset from the Roboflow. So that's require pip install Roboflow. Then we have to download the dataset. Let me run this cell. Okay, then we have to run this cell. Okay, it will take time, so wait for it. Let me explain you this thing that the data set which we have downloaded is the name of that data set is gun dataset 4, but I have to replace that name with to the name of the dataset which I required is weapon data detection dataset. For that I have used this os path.exit. If old name is exit and not all exit, that mean the new name is exit, it will change the name using os.rename. Otherwise this message will be shown. Okay, so let's get started. You can see this. Let me show you this Roboflow is installed. Now the dataset is get downloaded. Let me run it. Okay, see this gun detection 4, the name of this the dataset, but I have to change this name to the weapon detection dataset. For that I have to use os.path exit os.rename, so it will change that name. Now let me run this cell. Okay, the name will be changed. Now let me refresh it. See, weapon detection dataset. Now these are the libraries which will be required: Torch, Torchvision, data loader, transformer, CB2 and OS. Okay, now there is a need of why there is a need of custom dataset class, because we have to convert the image and a annotation file into tensor format and return into the format that our PyTorch is readable. Okay, so let me read this. Custom dataset class is credited to load images and their corresponding annotation file, convert them into tensor, and return them into a format that PyTorch object detection model can understand. Okay, that's why we require a custom dataset class. Okay, so first thing is the initialization. Self image directory means all the images part of the image folder. Annotations basically list of all the annotations file name of txt file names. Annotation directory, this will be the directory path. Transform means if any documentation is required, we have to apply to the image. So that's why it transform initially would be none. Now self.def.length give me the length of all the annotation, means how many number of images which we have. Okay, then get.item means it will return the images and images and annotation in tensor format, or in the format where the PyTorch object detection model will understand. So let's get started. The first thing is self and then idx. Okay, after get using the index, we can using this annotation self.annotation, which is a list of all the annotation file. Using that we can easily fetch the text annotation file name. After that we have to convert that image txt.file name into a image file name. So how we can do that? For that we just have to use os.path join dot self.image directory, the path of the image directory, and the annotation -4 means last four character will be not be there, means .txt. Instead of that last four character, .jpg will be there. So this way we create an image path. After that we will read that image. After that if that means it might be possible that an image is not present in an image directory, so it will return this error. Otherwise we have to you can already know that the image read by the cb2 in a bgr format, so we have to convert that into the rgb. So that we have to require bgr to rgb, so that's why we have converted it to bgr to rgb. After that we have to fetch the image width and height. So how we can do that? But you just use image.shape. You will get the height and a width. Okay, both. Now full path to annotation file means that now here we have to use the get the full path of annotation file. So how we can do that? Just use os.path.join self.annotation directory and the annotation. Okay, this will create the annotation file path. After that you can already know that annotation file path have a boxes, annotation details and a labels. So how we can do that? Just you can see, first thing I want to explain you that the format the labels is there. Okay, the format of the labels, let me open it. It's taking time, please wait. Yes, as you can see that initially it zero means zero is a class name. Then this will be the accent this will be the accenter This will be the X center and Y center. Then this will be the box width and the height. So in this in this format, the dataset means the annotation details is there. So how we can split that and how we can convert it into tensor? This will be the things which we do here. So first we have to create the empty list of boxes and labels. Then with open annotation file in read mode as f, everything will be stored in f. Then we have to loop through the f line by line. After that, data dot line dot strip dot split give me the all things into a list format. Okay, so how we into list format, so that we can easily fetch that. But one thing is that everything is in a string format, not in a integer format or a float format. So according to that, we have to do that. For that, just your class index first will be the class index. I already told you. So after fetching it, data dot zero, it give me the class name, but it is in a string format, so we have to convert it into the int format using this. Okay, the same way for the accenter. After, you can say this will be data dot one give me the accenter. It is in a string format. We using this line dot strip dot split give me the string in format list. So that's why we have to convert it to float. After that, this all thing, this till here, it is in a unnormalized normalized form. So we have to convert it into normalized form according to the image width and height, so that we have to multiply it with the width. And same way for the y center, we have to multiply it with the height. And same way for the box width and box height. But we want to require this format for the plotation of the object. We can say the bounding box around the image, around the, we can say the gun or a weapon. So we required x mean, y mean, and x min and y max. So how we can get that? So we can easily get that like this. For getting the x and x min and y mean, let me tell you, x mean and y mean is a top left corner coordinates of the bounding box, and y mean, y max, and you can say y mean and y max is basically the you can say, so not x max, sorry, x max and y max is basically the bottom right corner coordinates of the bounding box. So how we can easily how we can fetch that details? Okay, so the you can see the values, how we can fetch that. So that it's very easy. First we have to do box width divided by 2, then just subtract it with the x center. You will get the x mean. Same with for the y mean, and same way for the x max, and same way for the y max. Okay, now after getting it, we have to append that into the empty list like this: x mean, y mean, and x max and y max. We have to append that into the boxes list. Okay, it might be possible that multiple bounding box detail will be there, so that's why we have to append that into boxes dot list, or multiple labels will be there, so that's why we have to append it into labels format. You can see this and variable. This is class index plus one. Why we are adding the plus one here? Because zero is already fixed for the background, and zero is already fixed for background. So that's why we have to increment it one plus one into the class index. So that's why the class index plus one and into format. That's why it appended to labels. After that, we convert that into the tensor format like this, boxes and labels both. We convert that into the into tensor format. After that, if any documentation is required or transformation is required to the images, so we apply that in here. If the child blur transfer is not done, we will apply the transformation. After that, we will convert them the whole thing into dictionary format like target, boxes, and labels. And after that, we will just return the images and target. Okay. So this way the class custom dataset class is required. Now this is the main thing, how we can load a pretend model. You can see that we have only one class. Let me show you. So let me show you that how many number of classes which we have. Wait for it. Data.yml file. You can see that we have only one class gun here. Okay, and I already told you that zero index value is already fixed for the background. So that's why with the number of classes which we have is background and the object class. So it will be two here. Okay, and here will be not two object class. We have only one object class, that is gun. So that's why total number of classes which we have is two. And the model which we are using is a model.fast RCN ResNet50 FPN. The model which we are using is this one, Torchvision.model.detection past RCN ResNet50 FPN. So this is a model which we are using it. Now let me print the model before this in feature and this changes. Let me show you what we have to change, then why we are changing it. So what's the problem? Torchvision is not defined. Oh, I think so. I forgot to run this cell. Okay, just take time. completed. Now let me run it again. Okay, done. Now let me show you one thing what we have to change. See, here you can see that number of in feature will be 1024, out feature will be 91. Because Coco dataset and 91 classes, that's why it have out feature will be 91 and in feature is 1024. Same way for the out feature 1024. It is means this ROI head is not according to the number of classes which we have. Here number out feature is 91, but we have required only you can say 2, and here 364 is there. Why here is 364? When you multiply 91 with the 4, you will get 364 because bounding box have 4 values. Okay, so that's why when you multiply 91 will 91 with into 4, you will get 364, 4, 4, 9, 336. Okay, same way basically this thing is not according to number of classes which we have. We have only 2 classes, but we have it has 91 classes. So how we can do changes according to that? So let me show you how we can do that. First thing, you can say go to the model, go to the ROI head, go to the box predictor, go to the class score, and we will fetch the in feature. Means how many number of features, how many number of inputs is what is the value of the in features. Let me show you. Yeah, let me show you where it is. See, oh, see, go to the ROI head. Okay, go to the box predictor, go to the glass score, and easily fetch the in feature. Okay, so this way we fetch the in features which is required. Input channel we required, how many input channel is there. Now after getting the in feature, we have to change this. So how we can change this? Use model.roi head, we have to change. Box predictor we have to change. According to which to torchvision.model.detection.faster RCN faster RCN predictor, and this will change to number of features which we have and number of classes. So this way ROI had it change according to our number of classes. Now I already run it. Now after printing the new model, you can see this. When I print a new model, let me print it again. Let me run a cell again. Okay, see, now this number out features is 2 and number out features is 8. When you multiply 2 into 4, it will give me 8. And why we are multiplying it with 4? Because box predictor have 4 coordinates values, so that's why we are multiplying it with the 4 and you will get the 8 value. So now box predictor is according to our number of classes. Okay, so let's get started. Data loader basically load the data, you can say load the data set for which is required for training in the format which is required for the training. So this is train image directory, annotation directory. This is train annotation, means the list of all the annotation file presented in annotation directory. After that, using a custom dataset class, means here train dataset is the object of custom dataset. Here we passing the train image directory, train annotation, train annotation directory. Then a transformation is just convert them into the PyTorch tensor. This is a transformation which is required. So this way we make a custom dataset, and it's a case a custom dataset object. Okay, now here we use a data loader. Okay, so here we basically data loader create data loader for training. How we can do that? Just pass the train object of the class which we have created. Then the batch size will be 4, means every images is converted into batches, and each batch have 4 images, shuffle will be true. And here custom collect for detection model. Okay, so this way we create a train data loader, just a bit train data loader basically used for the training, and this way we use a data loader here. Now after that, how many number of, see, using this length functionality we get 1359, means train data loader. See, number of batches which we have is 1359. Okay, if you want to know how many number of okay, let me show you. Train dataset, the in train dataset is a function, so you can say it is an object of the custom dataset, and you have already to know that in a custom dataset there is one function length. When you run it, let me run it now. See, 5435 number of images for the training which we have, and when you convert them into the batches, it will give you 1359 has the number of batches which we have, and each batch have 4 images. Now setting learning rate optimizer. See, here we you can say optimizer and scheduler we are applying here. So let me explain you. See here, device is required means on which the training will be performed, whether it is performed on GPU or on a CPU. For that purpose, we use torch device. If torch if torch dot CUDA dot is available means GPU is available, then the device will be CUDA. Otherwise, it will be CPU. Okay, let me do it. So this will be get a device name. After that, we will means load the model or in a GPU or a CPU according to that the device which we have. After that, we require a number of parameters which is trainable during the training. So how we can do that? Just required we will loop over the model dot parameters and will give me the p. If the p dot required grade means there is one attribute, or you can say the attribute will be there, p dot required grade. If it is true, then that it will make the list of all the parameters which is trainable during the training. Okay, now let me set the optimizer. The optimizer which we're using is SGD, learning rate and the momentum. Okay, learning rate will be 0.01 initially, momentum will be 0.9. Momentum, what is using momentum is help accelerate training and reduce oscillation. Okay, this is required of the momentum. Here we set the optimizer. Okay, and define learning rate scheduler. How we can do that? Here scheduler is required to reduce learning rate by a factor of gamma every step size required. Let me explain you what is happening here. Torch.optimum.learning rate scheduler.step.lr. Optimizer, we pass the optimizer here, and step size will be 3. Reduce learning rate after every third epoch, and it will reduce by 0.1, means it will multiply the learning rate by 0.1, and number of epochs will be initial will be 4. Let me explain you. If initially you can say initially the learning rate value will be 0.01, you can say the learning rate value will be 0.01. 9 learning rate 2 will be there after every third epoch. It means it will in fourth epoch 0.01 will multiply with 0.1, and learning rate new learning rate will be this one. Okay, same way after seventh epoch, in seventh epoch the learning rate value will be multiplied by 0.1 and you will get this epoch. So that's why required the scheduler learning rate will be required. Now let me run it. Okay, but I will run it for just for the 2 epoch, you can see, because I already had a model which is trained on 50 epoch. So I will not do just for the explanation purpose. I will just run it for the 2 epoch. Okay, I will load the model which is trained on 50 epoch. I already have that, so that's why. Now according to it's my in some you can say during some training, you can say when you download the dataset on the Roboflow, more than 10 number of classes which is there. So for typing each class name by hand, or you can say manually, it will be hard. So we have just created one function which you can say load class name. It will go to the YML path. This is the path which has provided, and it will read the file in the read mode, and after that it will just load all the class name into this. It will return the basically all the class name present in that. So this way it will give me the number of classes which we have. It basically give me the class name list. Now here we will check the data loader. How we can check the data loader? What is the use of checking the data loader is that the bounding box which will be the bounding box detail which is standard by the custom dataset class which we have created is correctly bound the weapon or gun or not. How we can check that? Because if we do not check it before the training, then the model will not learn perfectly. Okay, so that's why we have to check the data loader before training. It's required. So how we can do that? Just use the iterator train data loader. Then next it will give me the images and target. Means here it will be the batch of 4 images and 4 targets, mean 4 details of each image details will be stored in this targets. So we have to plot just 2 images, so that's why we require plot or subplots. 1 row 2 column means 2 images will be there. Figure size will be 12 and 16, and figure will be figure basically presenting the entire figure. X will be the you can see the iteration over the subplots. Axis dot table will be converted into axis the here x into the 1D here. So since we have to plot the 2 images for the plotation, we have to use for loop for the 2 times. And here we're using the means we have to first fetch the first image from the batch we have, images batch. So for that we use idx, then permute, then CPU, then the numpy. So let me explain you what is use of permute here. As you can know that we have used two tensor. Let me show you. So here we use a two tensor and apply the transformation. As soon as we use a two tensor, basically convert the image dimension from HWC to CHW, and also make the images pixel value in a range of 0 to 1. Okay, so let me show you. So that's for that purpose, and for the protection we require the original dimension HWC. For in that purpose we use the permit 1 to 0, and also we have to make sure that the image is on a CPU. Then also we have to convert, means two times basically convert three things. First, it make the dimension from HW to CHW, then make the range of the pixel value from 0 to 1, and third, it also make the pixel value in a tensor format. So everything we have to means reverse the things to make for the protection. First thing, dimension change, then numpy, and after that we have to make the pixel value to the original pixel value. So first of all we have to change the dimension. For that purpose we use permute here 1 to 0. Then we have to make the numpy, because we have to convert image pixel value from tensor to the numpy. Then we have to make the pixel value range to 0 to 255. For that purpose we multiply each pixel value from image to 255 to make a complete original image. For better explanation, let me print everything here. Images idx dot shape, and after that print image dot shape. Then let me print the image before changing or making the pixel value from 0 to 255. Okay, now let me break the loop here and let me run it. So wait for it, will take time. So see, the dimension is CHW. After permute, its dimension is this. And as you know that all the pixel value you can say before making it normalize, its range is 0 to 1. After making it multiply by 255, its range is become like this. So this is that's why we are using this two line. Okay, so let me comment them, because now we do not require them. Just for the explanation purpose, I have done this. Then to get the labels, first of all, to get the labels, we have to use target.ids to fetch all the information. Target.boxes give me the boxes information, and the labels for each bounding box. We use target labels to get the label for each bounding box. As all thing is in a tensor format, so we have to convert it into numpy. So that's why we require numpy here. Benign will iterate over the boxes and labels at the same time. For that purpose, you use a zip. Then we have to generate a random color. For that purpose, use random.rendered 0 to 255. Okay. Then after fetching you can see now we have to fetch the bounding box details. For that purpose we use xmin, ymin, xmax and ymax box.s type. Okay, we will fetch the xmin, ymin, means xmin, ymin is the top left corner coordinates, and xmax and ymax is the bottom right corner coordinates. Then using a CPU rectangle, we will plot the rectangle here. You just pass the image, coordinates value, then a color and a thickness. Now put the labels. How to put the label? The for that purpose you put tags, then pass the images, then class name. As you know already we fetch the class name here. Just pass the label, and you already know that 0 is for the background. So to get the correct label, we use label dot -1. Then xmin, ymin, this is coordinates value where we start the text value. Then this is a font, this is a thickness, or you can just scale, then a color, then the thickness. Then just plot the images. Now let me show you the images with the bounding box, and this is checking the data loader that correct bounding box is apply on a image or not. Okay, now this is a training get started. So let me explain you that how for the training we are using the PyTorch. Okay, so let me explain you each line. So first we import TQDM. TQDM basically used for the visualization of the bar. So let's get started. So list of the stored training loss for the each epoch. So for storing the loss for each epoch, we have to make first the empty list. So train loss is that list. Now we will loop according to number of epoch which we have. For that purpose we use for loop here. Then first be the message which we want to display. The message is like this: starting the training of epoch. Then the training gets started. It's important is that model should be in a mode of training. Otherwise, no updation of the weight will perform. So for that, first of all, we have to make the important thing that we have to make the model train. So for that, this is line important, model dot train. Then initially for each epoch, training running loss is 0 for the calculation purpose. We have to make this training running loss is 0 for each epoch. Then we have to initialize you can say the tqdm. For that purpose we use tqdm function. Here we have to just pass the train data loader, the length of the train data loader, and the message which we want to display, and leave false means remove var after epoch. After getting this progress bar, we have to loop over this progress bar to make to get the images and target for each batch. Okay, so for each batch iteration we have to loop over the progress bar. Then we have to make sure that images and target has to be on the same same device, whether it is a GPU or a CPU for that purpose. So here is a forget pass where we just pass the images and targets. Okay, and the loss tick basically basically to store the loss after prediction made by the model. To get the losses, or you can say sum of all the losses made by the model, we have to loop over this for loss in loss tick dot values, and after that we have to sum up all the losses. This will be basically get all the losses are stored in this losses variable. After that, this is the important thing, clear all gradients means optimizer dot zero grade. Basically it make the gradient value 0. If we do not do it, then the previous batch gradient value will accumulate the current gradient value, and basically disturb the weights or updation of the weights, or the training will not perform very well. After that, backward basically calculate the gradient value according to the loss, and optimizer.step basically update the gradient value. So here make the gradient value 0, calculation of the gradient value, updation of the gradient value using the optimizer. Okay, after that we have to for each batch, we after calculation of loss for each batch, we have to store that into the running loss for the calculation for entire epoch loss. Then scheduler dot step, as you can see, scheduler dot step we have make where it's gone. See here, after defining the scheduler, we have to define it here, initialize it here for in a epoch for loop, not a batch for loop. We have to initialize it in a epoch for loop. Okay, then after for the calculation of epoch loss, this is the calculation done for the calculation of epoch loss. After that, we append that in a train loss. Then we just want to display it. Let me run this cell. Okay, so it's getting running it. Now we have to plot this train loss. How we can do that? First we have to create this epoch loss. See what is the use of this. Compute a list of all the epoch name number according to epoch number of epoch which we have. It's create the epoch log. After that we have to plot. So how we can use plot the graphs? Use plot the subplots figure.x1. Here x1.plot, which we have to plot epoch log means x-axis, then a training loss in a y-axis. Okay, and r dash means red color with a solid line. Label will be train loss. X label will be epoch, and Y label will be loss with color red. Title will be loss versus epoch legends, and the plot show. Okay, so it will be there. Now here we save the model. How we can save the model? For the saving the model, first we have to create the path, then use torch.save.model.stateDict.path. This way the model will be saved. Now we have to test the model. So how we can test the model? First thing, device which we have, that is be CPU or GPU. After that, number of classes. Then same way we will create the model. Entire thing will be similar. You can see that everything will be similar here. Till here everything I have explained you how we can create the model and why there will be number of classes will be 2. After that, how we can load the model which we have saved. So this line will load the same model. How we can do that? Model.torch state dict torch.load, then the model path, then the map location will be CPU. Then the model evaluation. Here we are not training the model, so that's why we have to model should be in a evaluation mode, and model of device will be the device which we have, CPU or GPU. Then we have to plot 16 images, so that's why we use plot.subplots. 4 by 4 means 4 rows, 4 column. Figure size will be 20 by 20. Here x, which is in a initially it is in a 2D format. When you will use x.table, it is a 1D format, just for the easy for the iteration over subplots and transformation. And one thing I have to tell you, that all means it might be it required that the transformation which we have required before training, it should be there after training, after you can say after during testing also. So that two times is applied before training to the images, so same thing has to be applied here. Then the test directory, then the test, we have to create a list of all the images present in the test directory. Okay, after that we have to plot 16 images, so that's why we use for loop will be 16 time. Image path, how we can get the image path means test directory means where's the path to join test directory. Then initially randomly select the image file name from the list of test list files. It will randomly select the image file name. This way we will create the image path. Then we have to read that image. How we can reading the image.open. Here we are using the pill, okay, for reading the image and convert it to RGB. Then image tensor, apply the tensor to the, apply the transformation to the images, transform image and squeeze 0 to device. Okay, then with torch no grade, initially no grade means no gradient will be there, no application will be performed. Okay, so that's why with the torch no grade. Prediction means just pass the image tensor. Okay, and zero index value because we are just passing the single image. To fetch all the prediction of the single image, you use zero index value. We will easily get the prediction of single image in the prediction variable, and after that we will convert that into the in a permute. Okay, image tensor dot squeeze 0 permute 1 to 0 cpu dot numpy. I will explain you why we are use this here in above here. Okay, then image np convert and multiply it with 0 into 255 because image tensor is in a tensor format already. I already told you to apply the transformation here, so we have to convert it into 255, multiply it with 255 every value. Then this way we will fetch the every details, and by we are converting it to the numpy because every values is in a tensor format, so that's why we are multiplying it with the numpy. Boxes label score, we will loop box label score at each same time. If the score, it will means the confidence value is greater than 80%, we can say if a score is less than 0.18. Okay, then continue, we do not require that. If the score is greater than 0.18 means the images or you can say the prediction made by the model is confidence is greater than 80%, those images should be plot, those images should be plot. Okay, now this will the, we can say map will be int and box, mean it will map everything x1 y1 x2 y2 value to the boxes of means the box value will be there, and into int format. This way we'll get the random color value, and after that we will just plot the rectangle and the, you can say the text. You can say this initially the text will be class name only, but here just we include one thing here, the confidence. We also we can say in text we include score also. After that we will plot the images and you can say tight layout. Now training is going on. Now let me upload the model which is trained on the 50 epoch, then I will show the result of that. Okay, let me come back. So this is a model which is trained on 50 epoch. Let me show the result of that. Okay, okay, so this is the result with the score and the class name, and it's pretty working very well. So I hope you understand something. If you had understand something from my video, from my explanation, please like, share and subscribe my channel. Thanks to all.